right, if you haven't gotten a chance already, go ahead and make sure that you kind of try this on your own to match them up based on what we have learned so far. So we're going to go over this right now. We have several different kinds of equations here, and then the names of those. So the very first one, what do you think that one is from the list? Okay, I would say the very first one is, this gives you a clue. This is quadratic. How come it's quadratic? Yes, if you see an x squared, you're talking quadratic. Okay, what about the next kind of equation? We've solved equations like this before. Rational. It is rational. Now, look, you have rational and radical, but it's rational. What about this makes it rational? Yeah, the dividing. The x is in the denominator. You have fractions. Fractions make it rational. So we can put a little note here, a over b, x squared makes it quadratic. Okay, what about the next one? What do you think? Any guesses? So you could call it that, but because there's not two equations and two variables, we're going to call it just linear. Why would I say this one is linear? Because there's no place where I'm going to be multiplying x times x. This is all x to the first power. So your gut instinct for that one should be, I want to isolate x, so that makes it linear. What about this next one? It is radical. What made you say radical? The square root. Anytime you see square root, or you might see cube root, or you could see fourth root. Okay, or, I mean, you could have a lot of different roots. But this index right here changes the kind of radical it is. But it is a radical because it has a radical sign. That specific radical is a square root. Okay, it's the default. If there's no index, the index is implied, and it's 2, and that's square root. Okay. What about the next one? We just solved some. Yes, absolute value. The next one, radical. The next one, oh, so that one has 3 to the x power. In fact, the x, the variable, is in the exponent. We don't have that one up here, and you're not going to be solving that until Math 111. This one is g, not listed, or you could call it, what comes after g, h? Exponential. That wasn't on the list, and you'll look at that more in Math 111, but you can tell it's exponential because the variable is in the exponent. That's what we call exponential. Okay, what about this next one here? This one is quadratic, so that's C. Here, also quadratic. Do you see where it's going to be quadratic because the x is going to end up being squared when you FOIL that out, or you could solve it using other methods. What about this one? This is actually 2 equations, and yes, this is a system of linear equations B. A system of linear equations has 2 equations, 2 actually linear equations, in 2 variables. And the variables, okay, the variables are x and y. So that would graph 2 lines, and our system of equation would be the point of intersection. Point of intersection is the solution. Okay, the solution is the point of intersection on the 2 lines. Okay, and then the last one, what do you think? Okay, and I can see why you said radical, but the thing is, actually, there's no variable here inside the radical, so that's just a number, the square root of 2, which is an irrational number. Since the x is still to the first power, we would call this actually a linear. That's because you don't have the variable inside the radical. So there's nothing that you're going to have to do to get rid of that square root. Okay, that's what we call a radical. Okay, so that was just a review on different types of equations. So in this section, we're going to explore mixed equations. So they're going to be all mixed up. We need to identify what kind of equation it is and how we might solve it. So let's look at this very first one. After you identify the equation, you would want to figure out how to solve. So here we have what kind of equation. Let's start by identifying the kind of equation this would be, and then we'll think about how we might go about solving it. Any thoughts? What kind of equation do you think this one is? Radical. It's a radical, right? Because you see the square root of x makes it a radical. Okay, if we can isolate the square root, what's the inverse of the square root? The inverse of the square root is the square. So if you square a square root, that undoes. So the very first thing we can do here is we want to isolate the radical. Look, that was tricky, huh? I just pointed to the radical, so I didn't have to write it again. So we want to isolate the radical. That means we want to get the radical by itself. What could I do to isolate the radical? So I'm going to write the square root of x plus 2 equals x. What can I do to isolate it? Yes, I want to, sorry, what did you say? Add 2? Subtract 2. I like that. Subtract 2 from both sides. We get the square root of x equals x minus 2. By the way, I could have written that as negative x plus 2, but I just think it looks better. Okay, now what I want to do to get this x out of the radical is what? Yes, I'm going to square both sides. Square both sides. What happens when I square the square root of x? I get x, because that undoes, right? So we isolated the radical, and then we are squaring both sides. What does this side equal? So that's step 2, square both sides. What do you have to make sure that you do when you square a binomial? FOIL! Thank you so much for remembering that, because that's one of the biggest mistakes. People will write x squared plus 4. But if you FOIL that out, you get x squared. Does anyone know? There you go, negative 4x plus 4. That's from the FOIL, okay? What should you do? Now this radical equation turned into a quadratic equation. So now we have to solve a quadratic. What should we do to solve a quadratic? To solve a quadratic, we would start by setting it equal to 0. Because it became a quadratic, set it equal to 0. So how would I do that? Minus x from both sides. I get 0 equals x squared minus 5x plus 4. How could I solve that? Well, there's a couple different ways. You might have learned the quadratic formula. You might have also learned completing the square. We did that last time. But we learned in the very beginning to solve quadratics by, or factoring, right? So what are the factors that multiply to a positive 4 and add to a negative 5? We can start with x times x gives us x squared. Negative 1, negative 4. And so that means x would equal what? Positive 1 and 4. So we can put that in set notation, 1 and 4. But notice this, it says we have to check for extraneous solutions. Sometimes you're going to solve these and you're not going to get answers that work. Even though you solved it correctly, it might not always work. So here we factored, and then we need to check. So I'm going to put some additional paper here just because I might run out of space. So let's go ahead and check this. So the first check is going to look like plug in 1. So I go back to my original equation, and I plug in square root of 1 plus 2. Is that equal to 1? 1 plus 2 equals 1. Wait a second. 3 equals 1. Is that true? Is 3 equal to 1? No, these are not equal. So therefore, 1 is actually technically not a solution. We solved it correctly, but it didn't work, okay? So we call that an extraneous solution. A solution that we find legitimately by doing all the right work, but in fact doesn't work. Okay, let's try 4. So we take the square root of 4 plus 2 equals 2. Oh, I'm sorry, 4. I'm plugging 4 in for x to see if it works. We get 2 plus 2 equals 4, and 4 equals 4. So therefore, that one does work. Now, you can also graph these on Desmos. Some of you were finding that some of your problems that you had were kind of challenging. And so, if you go to your Desmos, if you're not sure what's going on here, especially if one of the problems doesn't check out, I'm just deleting these old ones, we can take one side of the equal sign. I'm going to go square root of x, and then I want out of the square root plus 2, okay? And that's what that looks like, the square root of x plus 2. And then on the second line, I'm going to just type in y equals x, or in this case, I'll type in x. And you can see here, that's their point of intersection, 4, 4. If we go down to x is 1, they're not actually crossing there. So remember, the solution on the graph is when you set one side equal to y and the second side equal to y, and you're looking to see where the lines or the curves intersect each other. Okay, so that would be another way to check it using Desmos. Any questions on that? We solved it, we checked it, we found an extraneous solution. So that's important. We have to know that we're going to have to check